Hello, I am Muhammad Shafi'i bin Nur Hisam. My supervisor is Dr. Siti Shaida binti Sirat. So, I'm going to present my final year project with the topic of synthesis, spectrum characterization, and molecular structure of silver 1 complex containing bidentate phosphine and arsine ligand. So, in the modern world, silver continues to hold significant importance as a raw material in numerous industrial sectors, such as a sensors, synthesizers in the solar cells, nanomaterials and bioimaging agents, and lastly, materials for organic light-emitting diodes or OLED. These unique properties exhibited by these complexes and the potential utility they offer often motivated researchers to investigate further into the novel system using different ligands. Therefore, this flexibility when chelating or bridging ligands leads to the creation of interesting compounds that possess valuable chemical and physical properties. Then the problem statement. Why I'm doing this? In coordination complexes, flexible diphosphine ligand can act either as bidentate chelating or bridging ligands. So there is a postulation with a various factors including different anions, reactant stoichiometry, crystallization method, and the type of solvent employed in the reaction. Therefore, it poses a challenge to predict the structural properties with the geometrical flexibilities, ligands bite angle, coordination modes of ligand, and also lastly, the electronic properties of the ligands used. Therefore, the significance of my study is we are focusing to design and synthesize a pre-organized ligands that capable of controlling the structure and properties of the complex silver one with various group 15 of phosphorus and arsine as donor ligand. Therefore, my objective we are to synthesize and characterize silver 1 complexes derivative of diphosphine and diarsine ligand at a different stoichiometric ratio. And the second one is to determine the solubility of the synthesized complexes in selected solvents. So, moving on to this, the literature review of a silver 1 complex containing bidentate and diphosphine ligand. Then we know that the adaptive capability of the silver 1 complex is evident. It depends on the stoichiometric ratio or the nature of the phosphorus ligands. As we can see, complex with equimolar of silver and bidentate ligand stoichiometry exhibit diverse structural types. One of the example is as shown below is a type 6 with the phosphorus ligand act as a bridging ligands between the two silver metal atoms. Therefore, we also can say that it influenced by the length of the chain connecting the two donor atoms of the ligand, diphosphine ligand, and then therefore it can create a highly strained four-membered chelating ring if mononuclear species were to form, or the formation of the dinuclear species of type 6 is favored instead. And previously is a equimolar, and moving on with the 1 and 2 ratio molar. The stoichiometry are relatively rare and exist in two distinct forms, as we can see here, type 10 or type 11. Therefore, this remarkable flexibility of the silver 1 complexes to the formation of diverse molecular configurations when coordinated with chelating and bridging ligands. This variation in the structures of the series of silver 1 complexes can be attributed to the nature of the anions, encompassing factors such as coordinating ability, size, and shape. Anions can have a significant impact of the structure, and therefore it can what we call it assemblies through two main mechanisms, which is an ion act as a template or it can act as directly coordinated to the silver metal. With respect, we tend to avoid the presence of water uh, since Shaukatali indicated that it can promote the lattice to a two-dimensional hydrogen bond network. So, what is the application of the silver 1 complexes? Silver 1 complexes, especially diphosphine ligands, were found to have many various applications in chemistry and material science due to their unique properties and coordination behavior. It, uh, it also interested in their emissive properties, which we said that the complexes have a photochemical activation of the atoms involving argentophilic contacts results in the formation of excited states. And the second one, it also can act as a as an antimicrobial agents. And then this is my collection of the previous studies of a ligands, diphosphine ligands, with their general molecular structure, also with their ratio, solvent system, temperature, and also the methods of recrystallization. As we can see, is in what we call it, the diphosphine ligand usually act as a bridging or chelating, also with an anion ligand. Okay, moving on to our methodology. It's just a simple reaction. We just weight the ligands and the silver nitrate according to their stoichiometry ratio, and then we dissolve it in the solvent. Usually, I use ethanol, and then we reflux in at a constant temperature of 60 degrees Celsius for 1 hour. The ligand is dissolved. We introduce the solution of silver nitrate. And then after that, the crystallization process, we use the slow evaporation method in a dark environment. So as the results is the synthesis of the good of and clear single crystal structure that are suitable for X-ray diffraction was unsuccessful. Therefore, we only get for the first three compounds dppe, dppb, and dpae, we only get a white and opaque solid. However, for dppf, we get a yellow and opaque solid powder. Then the solid products, we for the correct decision, we use infrared spectroscopy and also melting point test. And then after that, we do the solubility test with the common organic solvent. And then for my results, as you can see here, for the first starting material, which is silver nitrate, is indicated by the IR spectrum. The bands that are near of the 1300, indicating the bands of ionic nitrate. However, it is absent in the ligands and also obviously in the complex or the product. But however, since there might be an overlapping or while so on, so I just propose that the structure with this type 6, what I can say is the dppe ligand act as a bridging ligand between two silver metal, and also the nitrate ligand chelating in a monodentate behavior. And then moving on to the second reaction, silver nitrate with dppb, uh, also the absence of ionic nitrate, but we can propose that the silver nitrate, but from our studies, that also ionic nitrate also can act as a bidentate chelating ligands. Therefore, its two oxygen atoms are chelating with the one silver metal. And then move on to our third reaction of silver nitrate and dpae. Uh, this might be an interesting because uh, it only involved in a equimolar stoichiometric ratio. Therefore, the arsine ligands chelating to the one silver atoms, and also nitrate also chelating as a monodentate ligand. And then my last reaction with dppf. This one is indicated by the what we call it the chelating ligand. This one is different because nitrate act as a bridging chelating ligands. It bridges between the two silver atoms. And then my melting point results. Also, it slightly differ from the referred crystal. However, from melting point, we can know that my complexes, we can what call it? Yes, analyze between it is a cationic compound or just a neutral compound, coordinating compound. And then solubility test, we can say that my complexes are polar because it dissolve mostly dissolve in the alcohol, which is a polar also. And then my conclusion is the synthesis of a silver 1 salts of nitrate with bidentate diphosphine and diarsine ligands was successful achieved by the thermal method. Yet, single crystal X-ray diffraction was unsuccessful to be produced. Therefore, the proposed structures was only based on the metal-ligand ratio used in the synthesis route, based on IR spectrum and comparison with the previous literature. However, moving on to the melting point testing, it was inaccurate since the complex was not in a crystal form with the high probability of amorphous, but as I said just now, we can differ between the ionic and coordinating compound. And lastly, the solubility test performed can be used for recrystallization of process after unsuccessful attempt of synthesizing the silver 1 bidentate ligand. Therefore, I recommend it to proceed to recrystallization process in order to obtain the crystal after unsuccessful synthesis of the product. We can explore the method of recrystallization such as slow diffusion between two solvents. It is ideal to start uh, with a drying of the starting material. Also, IR spectrum must be analyzed and repeated if necessary to avoid the presence of unnecessary solvent bands. And the third one, in addition, we can characterize the complexes even though if they are not crystals with the UVVs, elemental analysis, and also NMR. And then I think lastly, if we can further our study of the synthesized product in the form of its application in photoluminescence and also biological activities. I think that's all from me. Thank you.